Thanks, everyone. If you haven't seen already, VivoQuant had a recent release, version 3.5, with a variety of maintenance and new features integrated in. We had a really good Vivo scripting session with it yesterday, as Bill mentioned, and I'm going to talk a little bit about the release, a little bit about our future directions, and I'll do a little bit of a demo to show some of what we've been working on, and showing off some of the good work of the development team, as well as, of course, our testers and users who provide us with the feedback that drive what we do. So we like to show this plot kind of across the company, and I wanted to use it. It's kind of our translational plot of mass versus resolution and different sensitivities that you can get across the spectrum for different species. We have now images across a variety of formats, a variety of scanners, all the way from the small histology scale to human-sized patients, and VivoQuant is able to support really the breadth of the spectrum, and thus its multimodal and kind of multi-species ability to visualize and analyze is one of its core strengths. And you'll see kind of throughout our development, if you've seen our presentations in the past and what we're working on these days, we're just always striving to improve our ability to do multimodal analysis and to satisfy the needs of an imaging scientist looking to derive quantitative information from their images. So I'll go over a few things. We've been spending a lot of time on VivoQuant's multi-view, which we really see as the future of the visualization layout there. Some additions to the reorientation operator, as well as advanced bed removal tools. We've had a classic bed removal tool in there that operates in 2 dimensions in there for a while, and it's seen a significant upgrade this release. Some enhancements to our audit logging. So ever since we've been collaborating more heavily with the New Haven Core Lab team, we get a lot more clinical data and are working towards increasing our level of 24 Part 11 compliance and general good practices from the software standpoint, as well as some nice state-of-the-art algorithms that we've been integrating in for really a variety of tasks, including filtering, that I'll show here. And then last, I'll conclude with future work. So the multi-view, we did some work on this in the previous release. It's become significantly more user-friendly, I think, in this release, with the ability to flexibly merge and split viewports, as well as create all different types of layouts with up to a 5x5 array of viewports and visualize all 3 cross sections, any combination of time points, data set that you have loaded, ROIs on individual viewports, different window levels and things like that. It's become quite flexible, as well as easy abilities to zoom into what you want, to independently zoom in the different viewports. And if you have some radiology background, you might be familiar with hanging protocols, where there are predefined sets of visualization setups. We've integrated those in with some customary defaults, and you can save your own kind of visualization setups to disk to use later, share them with users, and so on. Our reorientation tool, we had a fairly rudimentary landmark registration in the distance operator before. We've really enhanced on that this release to provide landmark-based registration both in 2D and in 3D. This is really also the engine driving our autoradiography and what Bill mentioned earlier, cryofluorescence tomography reconstructions, where we have slices across, a frozen block that we then register together and compile into one 3D volume. That said, it's not only useful for that; it can be used for any pair of images that might be well registered by landmarks. And to that effect, we've integrated that directly into the reorientation tool. We've made it a lot easier to select your fixed and moving images, so you can easily select what you're registering to and what is being co-registered. Bed removal was a fun project and one that took a fair amount of time due to its complexity. The goal here being, the bed is not interesting to analysis typically and doesn't make your maximum intensity projections look very nice. So getting rid of it is a good thing, and segmenting it is really the hard part. Once you have that segmentation, you can remove it from the image using a simple mask operation. And the approach we went about here, and the approach that was done before, but previously only in 2D, we've done now in 3D and tried to make it as efficient as possible. We had to make a number of optimizations to make sure the 3D algorithm was quick, and we noticed quite a few interesting aspects of the optimization curve. So when you're aligning these two things in 2D, for instance, you have quite a few local minima that you have to get around, and you can clearly see kind of the global minimum here in the alignment, where this is the similarity cost function here, and getting into that space was really the challenge, and I think we've done a good job of that here. Now users can input their own beds and segmentations and use that for bed removal. So whether it's a 3D printed bed that you made on your own or one delivered by the manufacturer, you should be able to take it, make one manual segmentation, and use that in the future to get rid of the bed more easily and more robustly. Audit logging, as I mentioned. This goes, we went in a few different directions here, but one of them was in showing more information in your slice views and making that more customizable. So we had a pretty fixed set of defaults before. Now you can really flexibly choose what's going to show up on your image, whether you want the patient ID, series time. You can see all different DICOM tags that are available to your disposal to show on the screen directly, so you don't have to go digging through the DICOM header for them. And then, in addition to that, adding what we do in the DICOM header already, which if you haven't seen this before, whenever we create a derived image in VivoQuant, we produce a log using the DICOM derivation image sequence tag, which records the username that you're working with, the timestamp, the version of VQ that you're on, as well as details of exactly what the derivation entailed, whether it be the filtering algorithm and its parameters, or the reorientation matrix, or things along those lines. And we've really enhanced that here to make it very complete, so that a user can go in and not only see what was done, but also easily reconstruct what steps were done if they were to do those steps all over again, because they have those parameters at their disposal directly in the header. We've integrated some new methods. So in the filtering operator, these might be things that you've heard of. If not, I highly recommend checking them out. We're doing a series of blog posts on them, but in our NVCRO blog. But the adaptive non-local means denoising filter, it is an excellent denoising filter coming out of UPenn and Brian Avance, and there we have what's essentially a local moving window that looks in the neighborhood of each pixel, finds in each neighbor its neighborhood, and assesses the similarity between its neighbors and basically that pixel that you're trying to denoise, and assesses and interpolates what the new pixel value should be. One of its great enhancements beyond simple non-local means denoising is that it estimates kind of the interpolation function adaptively across the image and doesn't just use a fixed one throughout, which essentially means that the noise properties of the image are allowed to vary spatially, which is a more accurate reflection of what you might see. Mean and median filters were added as well. Median filter, for example, is really good at getting rid of speckle noise that you might see in your image. The symmetric normalization algorithm, we look forward to putting this in the reorientation tool in 4.0, but for now we've had really good success with it in the whole body atlas, or what we also like to call the multi-atlas segmentation tool. So it's a new deformation algorithm that we've integrated there, and it does a symmetric registration of both the fixed image and the moving image together in opposite directions, and kind of composes the transform to move your moving image to the fixed space. It's very it's been very robust for us, and in papers that have assessed kind of side by side different registration algorithms and pitted them against each other, it's come out on top in quite a few cases. In addition, N4 bias field correction, the algorithm was there before. We've extended the number of parameters available to the user, and we've improved its robustness, including the ROI that's used automatically, basically making it more user-friendly. You could definitely get it to work really well before. Now out of the box, it works quite robustly and with little need for adjustment. Before I continue on, I think I'll take a break and show you a couple of these things in a demo. So let me X out of here. Shortcut's not here, I guess. Okay. So this is VivoQuant 3.5. Oh, sorry. I can see it. Nice. It's still not working. Maybe I should just mirror.
Yeah, it should be. That's strange. All right.
Okay. All right, so let me load some data in here. Go to CT. And a pet image. So I'd like to start with the multi-view. So as I mentioned, this is kind of the view you used to get where in older versions of VivoQuant, you'd just be able to see, if you had two images loaded, you'd see your reference image on the left, a fusion of the two in the middle, and your input image on the right. There's really a lot more you can do here. I can select, for instance, the hanging protocol. That might make sense here. Let's say showing two whole bodies next to each other, and we see a nice zoomed in transverse image on the right, and the two different cross sections on the left. You can zoom and pan any of these individually, and kind of preserve these transforms throughout your processing, and go back. If, let's say, you want to take a closer look at the viewport at your bottom right, you can right-click on it, select full view, and look around here, and then when you're done, close the full view and go back to your original view. You'll see that all views are linked by default, although that can be toggled as well. There's a few places you can control the layout here to make it easier. You don't always have to go to the layout operator. The right-click menu gets you pretty far. If you want to look at the sagittal image here, you can easily right-click. You can select a different hanging protocol straight from here without having to go over to the other operator and just look at the one image, for instance. And yeah, there's the full view option here as well. One of the convenient ways to add data to or select which data you're visualizing is to drag and drop. So let's say I wanted to see the CT image over here, the PET image in this view, and then I could select both and view the fusion over here. So just some intuitive controls, drag and drop features, a nice user interface enhancements here. This view is still fully flexible. I can, from my layout operator, select as much as I want here to edit and set up my visualization as I like here. Multi-selection is also a good option here now, so I can multi-select and set all of these to, for instance, be transversal views. I can add rows and columns here. I can merge them into one so that I have one big view here. And this one ends up taking more space. But the flexibility is strong. I can then save this to my own hanging protocol if I like this later. For later, I can call this demo, and then if I'm messing with the view again and want to get back to that view later, I can select demo and go straight back to that hanging protocol. A number of operators that were previously only available in the slice view are now also available here, including filtering, modeling, arithmetics, annotations, and just plain navigation. So I can draw lines directly here, make measurements, and have a really flexible platform throughout the multi-view. For the next piece, I'll load a part of a small clinical data set. So let me go to, or let me just do this here. So as you may know, we have neurologist and radiologist configurations. If you're used to looking at clinical data or preclinical data, oftentimes the radiologist view is preferable for clinicians to get things in the orientation that they're used to. Here we have a piece, I guess, a few slices of a clinical brain, and I can, if I go to my layout operator, for instance, make this just size 1 and only view my transverse if I want. If I go to filtering, I can show you some of the filtering options that we have. So for instance, this adaptive non-local means filter, that's new. I can choose to filter the data. It is a slower method then, oh, we have a question. Oh, 5 minutes. Never mind. I'll be done soon. It is a slower algorithm than some of the other filtering operators, so we don't provide a live preview, for instance, like we do with the Gaussian filter, where here I can choose to increase the smoothing kernel and live see it, how that affects the image. That said, we do have parameters built in to help you with the performance of it. So this shrink factor it is an important one that lets you decide what resolution you're going to operate at with this filter. A shrink factor of 2 indicates that the image will basically be downsampled by 2 during its processing, and the resulting defiltering kernel will be applied at the higher resolution. Here, to get a nice quality, I'll just do it at the native resolution, append the results, and watch it run. Shouldn't be too slow. But for instance, for volumetric analysis, where you're trying to get detailed segmentations of the hippocampus, this filtering operator is hugely valuable to basically, if you're doing like a multi-center trial, you have images from different scanners, different sites. This really harmonizes them a little bit and makes them makes later algorithms like segmentation and registrations much more robust. If I want to look at these together, or let's say I want to create a difference image, that image basically I showed you in the slide deck, I can subtract them. And now I have 3 data sets over here. I'll show you, I'm going to create a slightly different layout to view them in and move the 2 new images over here, make them both transverse. And you can kind of see the increased quality of the image here after denoising. If I put a little bit of, do a little adjustment, you can see the difference image on the right of image number 1 minus image number 2, and you can see the changes that it's made. And yeah, the gray matter white matter contrast, it's very much edge preserving and does a really good job. So before I run out of time, I'll make sure and talk a little bit about some of the new developments as well. Let's see here. Yeah. So in 4.0.
Sorry, stream just has the wrong view. Just let me jump in for a second.
Oh, sorry. Duplicate. There we go. In 4.0, there's a little bit more on this in a talk later today, but we've been doing a lot of development together with our image analysis team to create nice visualizations of cryofluorescence data. This is a 3D reconstructed fluorescence data sets, and one where we've constructed a really neat volume rendering, where basically in the projection process, we find the edges of the patient and give those more opacity in the projection, and it really lets you see the profile and some of the interesting internal organs, and these are parameters that can be adjusted. You can see a little movie of it on the left of what happens when you adjust some of those opacity transfer functions. There's some neat work that's going on in 4.0 that's nearly done, and that'll be available in the next release. Along those lines, we're doing a lot of enhancements to the volume rendering, and there should be some really nice images coming in 4.0 to that effect. We're working on simplifying and enhancing a lot of our workflows. So as you know, we have different projection tools in the classic MIP and VTK MIP. We're going to consolidate that into one high-functioning, really robust volume rendering tool, retiring the slice view entirely and making that multi-view really user-friendly to users, as well as consolidating dynamic data in the data manager into one entry so that it's a little bit easier to work with and the frames aren't always split up, which should do a number to make a lot of workflows easier, including modeling, time series analysis of various kinds, and dynamic MR. With some of our ultrasound collaborators, we've been doing a lot of contracted tool development that's going into 4.0. We'll hear more about that later today. And 4.0 should introduce a number of modeling upgrades, both on the pharmacokinetic side and otherwise, for the future. I think it's time for the next speaker. Thank you very much.